Hello everyone, welcome to this lecture series. So this is the lecture series of basic chemistry, and if we talk about today's learning outcome, you will be able to understand about electrons and protons today. So in previous lecture I have told you some introduction part of chemistry, and we also learned about uh, atoms. All right, so what we learned about atom is that atoms are the smallest unit of matters, but here today you are going to understand about electrons and protons. Electrons and protons are subatomic particles, means they lie within atom. So this is going to be very interesting to know about electrons and protons. So let's start today's lesson with electrons. Here I have shown you a diagram showing an carbon atom. Okay, now in the middle you can see some red and blue balls. So these red and blue balls are in combined forms are called nucleus. What is nucleus? Nucleus is the core of any atom. So these blue balls are the protons and these red balls are neutrons. You can also see some plus sign in blue ball. So this plus sign is showing the positive nature of protons. Protons are positively charged. Now you can also see some green balls around the nucleus in a circles. Okay, so these green balls are having negative charge on them. So these green balls are representing electrons which revolves around the nucleus and have negative charge. Okay, so what are electrons? Electrons are the smallest components which revolve around the nucleus and they have negative charge. Now, if an atom doesn't have any net charge on it, then that means this atom is having equal number of protons and and electrons in it. Okay, the number of equal protons and protons and electrons, they balances out the charge. Okay, and neutron have no charges. So now in this picture you can also see some circles. These circles are the energy level and they are also called shells. So these levels or these shells contains some orbitals within which we can find the electrons. So electrons are present in orbitals which lies in these shells. If we talk about the energy level of these shells, it's like the shell which is near nucleus, it will have more energy, and the shells which are farther away from nucleus, it will have less energy. In the next slide I have shown you an illustration of the orbital of the helium atom. Here you can see some red and blue balls. So blue balls you can consider them as proton and red balls as neutrons, and the black balls revolving around the nucleus. Nucleus means the combined form of proton and neutron. So these are the electrons. So helium atom have two electrons, two protons and two neutrons. Because of equal number of electrons and proton, this helium atom is neutral. Okay, it have no charge in it. So it's a noble gas. And every atom wants to be like helium, or we can say it wants to be like noble gases. Why? Because they have their outermost shell complete. That means they have complete electronic configuration. The outer For complete electronic configuration, the atom should have 2 or 8 electrons in its outermost energy shells. Now we have talked about what is electron. Now let us understand the significance of electron. So first significance is electrons are very important to form chemical bonds, because Due to the transfer of electrons to one atom to another atom, there happens the chemical bonds. Okay. Now, second significance is that after watching the arrangement of electrons in an atom, you can determine the chemical properties of that element whose atom is um, whose atoms arrangement of electrons you are watching. So this is very interesting. The arrangement of electrons tells a lot about the atom of an element. Let's take some example. So, when the outermost energy level of an atom is almost empty, okay, then what does it do? It tends to give up its electron because it wants to attain the complete electronic configuration. It wants to be like noble gases who have complete electronic configuration. So it will like to give up its one electron who is making its outermost shell unstable. It wants to get stability, right? So the very good example of this case is sodium. Sodium symbol is Na. So here you can see the picture. In outermost shell, this sodium atom is having only one electron and it can give its one electron to some another atom. Okay, now let's see another case when the outermost energy level of an atom is almost full. Okay, but not completely full. It needs one, two, or three atoms to complete its outermost shell. So what will it do? It will grab some electron from other atom, and a very good example for this case is chlorine. In this given picture you can see that this is what exactly happening. The sodium is giving its one electron to chlorine, right? And in the right side you can see that sodium is having positive charge on it and chlorine is having negative charge on it. And now what does this mean? See, sodium is having positive charge on it. Why? Because we said that atoms, when have equal number of protons and electrons, they have neutral charge. Okay, they have no charge. But here in sodium atom, now because it have given its one electron to chlorine, now the number of electron is less and number of proton is increased. So that's why it is having positive charge, because in sodium atom now protons are in much number. Similarly, in chlorine now electrons are in much number. So this is the reason why they are having positive and negative charge. Now finally, the next significance of electron is that it can store energy also, and it is very important in understanding metabolism. For example, in photosynthesis, the light energy is captured and stored by electron, and then they use it to make glucose and other organic molecule, and this stored energy is used as the potential energy in their chemical bond. So this is the next significance of electron, that they can store energy also. Okay, and every time when a chemical reactions take place, electrons are shared and transferred between atoms, and hence this energy is shared or transferred. Okay, so while transferring the electrons, the energy is also shared or transferred. Now we have understood about electrons. Now let's jump to our next topic, that is proton. So you know something about proton, that it is a subatomic particle. It have positive charge, right? Its symbol is P. Now you will be surprised to know that proton also denotes something else. Means the proton can tell you about the atomic number of any atom. So what is it? So the number of protons in each atom is its atomic number. So suppose if an atom is having two protons in it, then will say that this atomic number is 2. All right. If an atom is having 6 proton, then its atomic number will be 6. So proton is equal to atomic number of atom. Number of proton equal to atomic number of atom. All right. So this was about proton. Now, the name proton was given to the hydrogen nucleus in 1920 by Ernest Rutherford, because in previous year he had discovered that. And this hydrogen nucleus is known as the lightest nucleus, and it can be extracted from the nuclei of nitrogen also. Okay, so this is the reason why this hydrogen became the fundamental particle and building block of all the complex atomic nuclei. So this was all about electrons and protons. Now let's move to objective questions. So first question is, how many protons are present in helium atom? So answer is B, 2. Second is, which among the following is the lightest nucleus? So the right answer is A, hydrogen nucleus is the lightest nucleus. So we have covered these topics in today's lesson, and thank you so much for watching this lesson.